Hey, PreCalc kids, our last video. Here we go. Notes out, binomial theorem and probability. Notes out, and away we go. All right, to introduce this, we're going to look at this problem. Managers at the Eco Landscaping Company know that a mahogany tree they plant has a survival rate of about 90% if cared for properly. If 10 trees are planted in the lot, in the last phase of a landscaping project, what is the probability that 7 of the trees will survive? Let's consider a similar problem. Let's look at the probability that 4 out of 5 trees survive. This is actually a binomial form. What's the binomial form? Well, binomial implies 2. What's the 2 choices? Either the tree is going to survive, right, or the tree dies. Those are our 2 choices. That's our binomial. So survives plus dies has to equal all the trees, and that's going to be to the fifth power. Why to the 5th power? Because that's our number of trees. And this turns into what we did last chapter with the binomial theorem. So that gives us s to the 5th, right? There's one way that all 5 trees survive, plus, and we can use our trick here, 1 times 5 divided by the first term is 5, s to the 5th d. There are 5 ways then that 5 trees survive. 4 minus 1. 4 trees survive and 1 tree dies, because it could be the first tree, the second tree, the third tree, the fourth tree, or the 5th tree. Plus, we'll keep going, 5 times 4 is 20, divided by 2 is 10, s cubed d squared. There's 10 ways that 3 trees can survive, 2 trees can die. There are 10 ways that 2 trees survive and 3 trees die. There are 5 ways that 1 tree survives and 4 trees die, and there's only 1 way that all 5 trees don't make it. Right? Now what are we going to do? Well, now we know our success rate. What's our success rate? The probability that a tree survives, well, we got that from the problem, 9 out of 10. That's 90%. Probability it doesn't survive, well, that's the complement, 1 minus 90, which is 0.10. Now we want the probability that 4 out of 5 trees don't survive. That's our probability that 4 out of 5 trees survive. That's our 4th term. So 4 trees survive, 1 doesn't make it. So that's our polynomial 5s to the 4th d. And we're just going to plug in our numbers. This is 5. The probability that a tree survives is 0.90. There's 4 of them times the probability a tree dies. That's 10% to the first. We're going to multiply that out, and that is 0.3281, or about 32.8%. So there's a 32.8% chance that 4 trees survive and 1 tree dies. That's our expansion of binomial. Number 1, refer to the application, our story problem. 5 mahogany trees are planted. What's the probability that at least 2 trees die? So now what do we have? We have the same idea. N is now 5. Our success rate is still 90%. The probability tree dies is 10%. And we actually are using the same formula because we're still doing 5 trees. So this is s to the 5th plus 5, s to the 4th d, plus 10 s cubed d squared, plus 10 s squared d cubed, plus 5 s d to the 4th, plus 1 d to the 5th. Now, what do we want? We want the probability that at least 2 trees die. Well, if at least 2 trees die, that means we're looking at 2 trees die, 3 trees die, 4 trees die, and all 5 trees die. We're going to plug in the numbers for that. That's going to go like this. This is 10 times 0.90. Wherever there's a success, that's our 0.90. Wherever the tree dies, that's a 0.10. So 10 times 0.90 cubed times 0.10 squared, plus 10 times 0.90 squared times 0.10 cubed, plus 5 times 0.90 times 0.10 to the fourth plus 0.10 to the fifth. And if we plug all of that into our calculator, we get a really small answer, 8.1%. Why is that so small? Because most trees survive. So the chances of 3 trees, 2 trees, 1 tree, or no tree surviving are really small. So that gives us a really small percentage. How else could we do that? Well, there's another way we could do that. And it actually would be a little bit faster, and that is to look at the complement. What's the complement of at least 2 trees die? That would be at least 2 trees don't die, and that's s to the fifth and 5s to the fourth. So if we look at that, that's going to be 0.90 to the fifth plus 5 times 0.90 to the fourth times 0.10. But we don't want that value. We want the opposite, which is the complement. So 1 minus these 2 has to give us everything else. And you can check that on your calculator. We also get 8.1%. Example 1, about 70% of the questions created by a random computer test generator for a science program are multiple choice. The rest are true, false, or matching. What's the probability that at least 3 of the 5 questions generated for a short quiz are multiple choice? So what do we have? So the probability of the question is multiple choice is 0.70. What's the probability of getting the rest? That was either true, false, or matching. The probability of getting a true, false, or matching combined is the complement of 0.70, which is 0.30. We're still to the 5th power. So we're still using our multiple choice plus what I call these R for the rest, whatever you want to call it, to the 5th. So we're still using our same formula. When we go back to red, that is m to the 5th plus 5 m to the 4th R. Right, there's only one way all questions can be multiple choice. There's 5 ways that 4 questions can be multiple choice. 1 can be the rest. And again, that's either if that other question is 1st, 2nd, 3rd, 4th, or 5th. Those are 5. Plus 10 ways. We could have 3 multiple choice. The rest are, and there's 2 of the rest. There's 10 ways we can have 2 multiple choice, and there's 3 others. There are 5 ways we can have 1 multiple choice, and there's 4 others, and 1 way that there are 4 of the others. That's a 5. Okay. And again, what are we going to do? Well, we want the probability that at least 3 of the 5 generated are multiple choice. So at least 3 is 3 or more. That's this term, and this term. And so we're going to plug that in. That's 0.70 to the 5th plus 5 times 0.70 to the 4th times 0.30 plus 10 times 0.70 cubed times 0.30 squared. We're going to plug that into our calculator, and that's 83.7%. Why is that such a big answer? Because multiple choice is the bigger percentage, so it makes sense that we're going to have a bigger percentage here. These other 3 are going to be really small because they're using more 0.30s, and these were using more 0.70s. Next thing is, and we do actually do this a bunch in statistics, and that is a binomial experiment. Problems that can be solved with binomial expressions. They have these properties. Each trial has exactly 2 outcomes, right? We've looked at that before, either multiple choice or not multiple choice, either success or failure, right? Either the tree lives or the tree dies. Those are our 2 choices. There must be a fixed number of trials, can't be infinite. The outcomes of each trial must be independent, so a matter that 1 tree lives or dies can't affect another tree living or dying. And the probabilities are the same in each trial. Number 2, 8 out of every 10 persons who contract a certain viral infection can recover. If a group of 7 people become infected, what's the probability that exactly 3 people will recover from the virus? And I gotta get my right paper here. Here we go. So let's identify our pieces. What's N? How many people are we talking about? Well, there's a group of 7, so N is 3. And we're going to turn this back into, we're going to go back to our binomial formula of N choose R. x to the n minus r, y to the r. So the question is, what's r? And that's going to be our other number, which is 3. We're going to define x as the recovery rate. What is our recovery rate? That was 0.80. Y is our not recovery, and that's 0.20. And so we're going to plug all of this into our formula. So this is n choose 3, x cubed, y to the 4th. And that's going to give us 35 times 0.8 cubed, 0.2 to the 4th. And that gives us a very small 0.029, which is 2.9%. Check point 2, if a group of 9 people become infected, what's the probability that exactly 5 will recover? Well, now n is 9, r is 5. We're going to use our formula n choose r, x to the n minus r, y to the r. That turns us into 9 choose 5 times 0.80 to the 5th, 0.20 to the 4th. We'll put that on our calculator, and that's 6.6%. Example 3, refer to the application at the beginning of the lesson. What's the probability that 7 of the 10 trees planted will survive? Again, we're still using our formula, n choose r. Here we have survivor to the s, and failure is n minus r. What's that going to be? We're actually going to flip this around. Yep, this is good. So we have 10. And we're choosing 7. Probably that 7 trees will survive. What's the survival rate? That's 0.90 to the 7th. And then 0.10 cubed. And when we plug that into our calculator, that is 5.7%. Check point 3, in Lisa's art class, 1 out of 5 paintings. Somehow I zoomed out on that. 1 out of 5 paintings that she makes will be chosen for an art show. If she is preparing 9 paintings for the competition, what is probability exactly 2 of them will be chosen? Well, what's our probability of success? Well, 1 out of 5, that's 20%. So our failure, probability of our failure is 0.80. What's n? Well, we're going to choose 9 paintings, and we want r is going to be 2. So we have 9 choose 2. Probability of success is 20%, 0.2 squared. If 2 are chosen, that means 7 then are not chosen. We're going to plug that into our calculator. That is 30.2%. Last book homework assignment of this semester. 13.6, page 878. We're going to do 4 through 12 together in class. You're going to have 13 through 26, 34, and 35. Have a good day, Maroons.